Hey guys, in this video we are going to talk about section 2.2. This is going to be some stuff that you probably studied over a long period of time in Algebra 2, and we're just going to, it's kind of like a little review here so that we can use this. So quadratic functions and modeling. Here's a bunch of information you probably learned over a long period of time. But your quadratic functions, they are polynomials with a degree of 2. We have the standard form of writing those where you put it with your highest exponent and then they go in descending order. So your squared term, linear term, and then your constant. The leading coefficient is not going to be 0. And then your vertex form is the other way to write it, where you can clearly see your vertex. So the beauty of vertex form is that we're able to kind of use just the formula to know where our vertex is and to kind of know how our function is going to look. So when in vertex form, the h and the k, those give you your vertex point, and the h will show you another way that you can find h if you don't have it in vertex form. Maybe if it's in standard form, you can use this guy, the negative b over 2a. Right? So if it's in standard form, you can get that h from your vertex by doing that. However, in vertex form, you just grab the h and you grab the k and it's good to go. So it's easier. If the a value, whether it is standard or vertex form, if your a value is greater than 0, then you know that it's going to be concave up. You'll see that your parabola faces up. Whereas if your a is less than 0, you know it's going to be concave down. Okay. Your axis of symmetry is at where your x is equal to negative b over 2a. Notice that that matches the h from your vertex. Your axis of symmetry is that little invisible line that goes through the vertex, and it shows just like how it's the same on either side of that line. Okay, it's a little invisible line that kind of cuts your parabola in half. So it's going to go through that vertex. That's why these two match. Okay. Your y-intercept's pretty easy to find. That's if you just plug in a 0 for your function. If you plug in a 0 for your function, the only thing that you're going to get out of it is that constant. So if you ever want to know what your y-intercept is, just look at whatever the constant is, and you know where your y-intercept is. Easy peasy. Your x-intercepts are a little harder to find. You're going to see your quadratic formula here, and that is something that you've used to solve for quadratics before, and that's because it helps you find where the x-intercepts are. If you know where the x-intercepts are, that's how you've solved quadratics with that formula. So you can either memorize it just the plain old boring way. We've learned a song in class before, so however you do have to learn it, okay? There are other things with quadratics as well that we'll get to whenever we need them, but for right now, this is kind of just a rundown of some things we need to know, okay? Let's try some problems. Now, we have a problem here that's been written in standard form, and the question says that we need to write this in vertex form. If you do not remember the steps for completing the square, I suggest that you go back and you watch my video that I made on completing the square. It is listed on the same page just above this video. I suggest that you go back and watch that because it will help to be able to do what we're going to do, okay? Because those are the steps. So the first step for completing the square, and that's what we're going to have to do in order to write this in vertex form, is we are going to group together our x's. So I'm going to put my x's together. It's nice that they're already written one right after the other. In standard form, they usually are, okay? Then the next thing that we're going to do is we're going to factor out a GCF, but not the GCF in its entirety. We just want the coefficients. So look at your 3 and your 12. The greatest common factor of 3 and 12 is 3. So I can take that out. I'm going to leave the x's though, okay? So we're still going to have an x squared, and then we'll have plus 4x on the inside. All right. Here comes the completing the square step. Okay, what we are doing is we're going to create a perfect square trinomial inside of here. And you may ask how we're doing that. We only have 2 terms. We're going to make it have 3. So we're going to add a number in there. How do we know what number to add? That's where we're going to do the completing the square step, okay? This is kind of your big idea from that section, which is we are going to take half of your linear term, so half of this guy, okay? And then we're going to square it. 4 divided by 2 is 2. 2 squared is 4. This is the number I want to add into this little set of parentheses. Now, here's something we got to be careful about, though, because we didn't actually add 4. Think about this. That 3 is being multiplied by that 4. So really, we added 12. Okay? Because that 3 is being multiplied by that 4. Here's the deal. I can't just willy-nilly add numbers, right? This is what we discussed in that video. I can't just add numbers into problems and say that that's okay. I can add the value 0, okay? So I technically added 12 to this little chunk, and I can't just randomly add a 12 to things. I can add 0. So I added 12. In order for that to actually have been 0, I need to take 12 over here. If I add 12 here and I take 12 here, I actually didn't add or subtract anything total, okay? All right, so what we're going to do here is we are going to rewrite this, but you're going to see these new values. Remember how we said we're adding a 4 in here? It's just that that value actually was a 12 because 3 times 4 was 12. That's why we have to subtract a 12 out here, and we get minus 1. The nice part about this is we just created a perfect square trinomial, which factors really, really pretty. It factors to be x plus 2 times x plus 2. Look at this. X times x, x squared. 2 times 2 is 4. 2 plus 2 is 4, right? And with those two things being the same, we're able to write this in vertex form. I can see here that my vertex would be the number -2, -1. I can also see that there's been a vertical stretch done to my function, right? That's what that 3 tells me. So there's a lot of information I can gather by looking at this in vertex form, and that's why we like to do that. We don't always like standard form. Vertex form a lot of times is prettier. So there we go. All right, we're going to do another one that's kind of similar so we can get a little bit more practice. The next one says that we're going to use vertex form, meaning that I'm going to have to find the vertex form first. They want us to use it to find the vertex and the axis of symmetry for this problem. Yes, you can find those things with it being in standard form. That's possible. But I think it's important that we practice being able to move from standard form into vertex form. So that's what we're going to do, even though there are other ways to do what they're asking, okay? The first part they had said was use vertex form. So I'm going to find the vertex form. That means I've got to complete the square. So we're going to look at my original function. I'm going to group together my x's. Nope, they didn't even give that to me in standard form. Y'all, look at that. I was assuming. Hold on. I didn't look at it closely before I started writing. So they did not give this to us in standard form. They actually just kind of scrambled up the letters. We want to put the x squared term first. Okay, and then we're going to put the next one. That was a positive 6x. All right, and then we're going to have that constant at the end. So this was me kind of rearranging it and grouping those x's together at the same time. Now, the next thing we're going to do is to take out the greatest common factor of my coefficients. So I'm going to take out a -3. We have x squared plus, it's going to be minus 2x. Okay. Really, it's not even just looking at the greatest common factor. Really, what we're doing is taking out the a value, factoring out the a value. So that way we end up with just a plain old little x squared in there with nothing in front of it. Okay? All right, so let's look here. We're going to figure out what we need to add. We're going to do that step with the completing the square. If y'all would look at that linear term, which is a -2, we're going to take half of that linear term and square it. Well, negative 2 divided by 2 is a negative 1, and negative 1 squared is 1. We're going to add 1 into that binomial. But remember what we were saying earlier, guys. This was not actually the value 1 to this term. This actually added a negative 3, right? Because that negative 3 in the front. So yes, it's going to look like a negative 1 when we write it, but the value was actually a negative 3, which means I need to add a positive 3 over there. So this gives me negative 3 times x squared minus 2x plus 1 minus 2. I can go ahead and factor this. If you want to skip a step, you can, because the perfect square trinomials will always factor really, really pretty to give you the same thing. So if you just get in the habit, you can jump straight to this vertex form and skip the second to last step. Okay? But what I can see here is they said find the vertex. Well, okay, vertex, that's going to be at HK, right? So this is going to be a positive 1, negative 2. You're going to take the opposite for your H, okay? The opposite. And my axis of symmetry is going to be at the line x equals whatever the H was, x equals 1. That's all they asked me for. So that's cool. We did our got it in vertex form. We can find the vertex and the axis of symmetry. All right, guys, we are getting close to being done, but we need a modeling problem, okay? So we're going to talk about what does vertical free fall motion look like, okay? You think about if you throw something up in the air, gravity is going to eventually bring it back down, right? So I'm thinking like when we talk about vertical free fall, we're thinking of throwing something up in the air. Well, eventually that's going to come right back down, okay, because of the force of gravity. So what we're seeing in here, this is information for our formulas, and I'm going to bring this back while we're working a problem in just a second. But this is information on the formulas that we can use to represent the velocity and to represent the height of the object that's been thrown up in the air, okay? So T is going to represent time, okay? G in here is actually going to be talking about the acceleration due to gravity. Remember how, like, if you throw something up in the air and it starts falling, it's actually going to get faster and faster. That's why it hits the ground harder if you've dropped it from a higher elevation. So there's acceleration due to gravity, okay? And that's what you're seeing with these values. If you want it in feet per second squared, it's 32 feet per second squared. But if we want meters, it's 9.8 meters per second squared. So it is a constant, actually, that G is. It is a constant. But the reason we're putting the G there is because in some problems, they might use feet. In some problems, they might use meters. And we've got to pick the right one to use for each problem. Okay? But that is a constant. That's never going to change unless you are like on a different planet, okay? Now, if we're looking at V0, this is the initial vertical velocity, okay? That's at the beginning. How fast is the object going at the beginning of our situation? And SO is the initial height, okay? So here we go. We're going to do a problem. I'm going to keep this handy so that we can pull that back when we need it. But we are going to do another example here, okay? So this is example 3. See if I can get all this on here kind of without... Okay, you can kind of see that at the top. Okay, we have a baseball throwing machine, and it's going to throw a ball straight up in the air with an initial velocity of 48 feet per second, and it's at a height of 3.5 feet, okay? Now, they said that we're going to write an equation modeling the height after t seconds. Then we're going to find the maximum height. How long will it take to reach? So I want an equation to model the height. That means that we are going to be using an equation like the S of t from up here, okay, to model that height. So let's get going, okay? We want to make an equation for my height s of t. Okay, now they said write an equation modeling the height after t seconds. Keep in mind, we are working with feet in this problem. They've shown me that. So when I use my gravitational constant, we're going to be using the 32 feet per second squared. All right, so we're going to start filling through this equation and plug in the numbers that we need. We have 1/2 times my gravitational constant, or that acceleration due to gravity. That's going to be the 32 for g. Then times t squared plus my initial velocity. Did they give us an initial velocity? They said an initial velocity of 48 feet per second. So my V0 is 48 t, and then plus my initial height. My initial height, 3.5. All right, so for my formula, really I just need to clean up one little thing here. The 1/2 times 32, this is really negative 16 t squared. And then the rest of it we can just repeat. There's your equation. That will model the path that the ball is making, okay? Models the height. All right, now the next one says find the maximum height and how long will it take to reach this height. So what we're going to do is we're going to take this, okay, I know I'm getting rid of the problem, but we're going to take this thing and plug it into a graphing calculator. Let me get rid of some of my papers, okay? Just that original one. Okay, so we're going to take this thing and plug it into a graphing calculator. So, hold on, I lost mine. All right, I'm using my NumWorks calculator. You can use whatever one you like. Whew, the brightness is up high. Somebody's changed these settings. Okay, so what we're going to do is go to your graphing thing, and we're going to input our formula here, okay? So I'm just going to type in what we've got. We've got a negative 16. I know it says x, that's fine, x squared. Then we're going to say plus 48x plus 3.5, okay? So you just make sure you've typed everything in correctly. A lot of times I mistype things, okay? But there we go. We've got that typed in. What we're going to do is go up to the grapher so that we can see what this thing looks like, okay? If we wanted to really, we can go to auto and it'll give us a nice pretty picture. Now, you can move this little cursor and you can try to estimate where that maximum is, but you may or may not actually get it on the right place, because we're not using the max finder right here. So what we should do is use our max finder on our calculator, okay? So we're going to go up here to where it says calculate. We're going to hit find, and we're going to say find the maximum for me. That way they tell me exactly where it is. I don't have to guess if I'm getting it right, okay? See if I can get this where you can see. They're showing me that my x value is 1.5. My y value is 39.5. So I know that's kind of blurry, but that's what we're going to use. They said find the maximum height. So here's my max point, okay? My max point was 1.5, 39.5. Okay? This guy's talking about time. This guy is talking about height. Okay? So when they said to find the maximum height, my maximum height is 39.5 feet. Now they said, how long will it take to reach this height? We're going to say it takes a time of 1.5 seconds. That's what we're supposed to get, and we can just use that calculator to get it.